In this video, we'll give continuity to the start of the partial differentiation and we'll solve an example. And in this example, we have a function u and use a function of x and y. And what we want to do is not find partial derivative of this u with respect to x and y. We just want to prove that if you take the partial derivative of this function first with respect to x and then with respect to y, it's going to give us the same result as when you take the partial derivative of this same function with respect to y and then with respect to x. So what basically tells us here is that first we have to find the derivative of this function with respect to x, and then we have to find with respect to y. And here we have to find with respect to y and then with respect to x. So this is the order in which we have to do this kind of things. So this same representation can also be given as d del by del x into del u by del y. And the same thing for the second case, del by del y, del u by del x. So this is the same thing as this, and this is the same thing as this. So if you put in that form, in this form, it's easy for you to remember that we are starting from this point and we're going to this point, and here we're starting from this direction and we're going to this direction. So this should be the order in which we solve our given problem. So starting with it, we have u, so I can just rewrite u natural log of x squared plus y squared. So this case here is a case of a logarithmic function, and in logarithmic functions we have seen how to solve them. In the playlist we have about the derivatives, which you encourage to go through it. And in this kind of rule, what you do when you have a log function is that if you have a function, let us say y is equal to natural log of some function u, if you want to find the derivative of that function, what you do is derivative of the argument divided by the original argument. So this is the case in which we have to apply that same rule. So starting with that, make the derivative of this function using this first part, and then we're going to do with this part. So with this part, what you do is first of all, derivative of u with respect to x. This is equal to, see, in this form, how to do is the partial derivative of the argument divided by the original argument. So because with respect to x, we have to find the partial derivative of this argument here with respect to x. This is going to be 2x. So what we'll have is 2x divided by the original argument. The original argument is this. So this becomes x squared plus y squared. So we have found the partial derivative of this function u with respect to x. So the second thing that we have to do right here is to find the partial derivative of this partial derivative with respect to y. So how is going to be? This is going to be del x del y u squared. So now what we want to do now, we want to find the partial derivative of this with respect to y now. So how to solve this kind of situation? First of all, because we're dealing with y now, our x is treated as a constant. So we just can put this 2x outside, and then we say this is multiplied by 1 divided by x squared plus y squared. We are still solving, this is not the end of the problem. So this can also be represented as 2x into x squared plus y squared. But this, because we've pulled it up, now it becomes minus 1. And for us to solve this kind of problem, as we've seen in the playlist about the derivatives and the rules of derivatives, what you do now, we have to use the power rule. What the power rule says, the power rule is if you have a function, let's say y is equal to u, and u, for example, let us say raised to into some x raised to some number n, its derivative is going to be this n will come down, and then we're going to have ux raised to the power n minus 1. This is how we use. So this ux here is just to show that this function may be a function of x, as I'm representing this function as y. So applying the same logic, what you're going to have now is 2x is a constant, so it should be kept as a constant. So it becomes 2x because we're dealing with respect to y, into, now this is the n and it has to come down, becomes minus 1. And then now what we have to do is to write the function plus y squared. We have to increase this power of n, so it becomes minus 2, into now the partial derivative with respect to y of whatever is inside, which is this argument. So this is going to be 2y. So this is the same thing as if you say 2x raised to minus 1 into 2y, all of this divided by x squared plus y squared raised to 2. When you take it down, this power becomes positive. So as a result, what you're going to have is minus 4xy divided by x squared plus y squared, all this squared. So we have found the first part. This one is done for us. So the next thing to do is go to this part, and then we have to check the result if both are equal. So coming down to the second part. In the second part, we are starting with du del u by del y. So the same function, this same function u, now starting with respect to y. So what happened now is that because we are doing this, is the same rule of log. So if you make the derivative of the argument as we did over here, what you're going to have is 2y divided by x squared plus y squared. First part is done. Now I have to find the derivative of this function, which was with respect to y, now with respect to x. So I have del by del y by del x, all this u squared. So how is it going to be? This is basically the same thing we have done for the first case. What we have to do is just to take this denominator and put it up so we can solve it easily. But we have to notice now that as we're taking this function now with respect to x, this y becomes a constant. So we're going to have 2y into, when this comes up, becomes x squared plus y squared raised to minus 1, as we did in the previous case. So this will become 2y into the same rule applied for the power, minus 1 here. This becomes x squared plus y squared raised to minus 2, and now the derivative of this function with respect to x of this one is going to be 2x. So as a result, what we have here is 2 into 2, it will become 4xy, then we have a minus sign here, so it becomes minus 4xy. This had power minus 2, so the same thing that we can do is to put it in the denominator, and then the power will become positive, y squared raised to 2. And as you can see, this final result, when we take this function with respect to y first and then with respect to x, is the same thing as we have this function taking its partial derivative with respect to x and then with respect to y. Hence this condition that we had to prove was proven.